Okay, in this video we're going to continue looking at quadratic functions in vertex form. This is part 2 of the same video that we just had. In the last video I didn't write the quadratic or the equation in vertex form. In this video we have the version right here. This is our function in vertex form. A is the same value as before. As you remember, our other function was f of x or y equals ax squared plus bx plus c. Now we replaced the b and the c with an h and a k. Now we have negative h and positive k here. Positive h and positive k is the vertex, the x and the y of the vertex. A is still telling us whether or not we stretched it out or we shrank it, depending on what the factor of A is. If A is if the absolute value of A is greater than 1, we're going to stretch it out. If it's if the absolute value is less than 1 but greater than 0, we're going to shrink it up. It's going to get shrunk. And if A is negative, we're going to get a reflection on the x-axis. So it's going to flip over the x-axis if A is negative. So all of those things happen with A. H and K is just your vertical and horizontal shift. This H shifts it right or left. The opposite, the mistake I made in the last video is I treated it as the same number. We need to go the opposite value of H here. So if it's negative 5, we would move it right 5 units. If it's positive 3, we would move it left 3 units, or negative 3. Now K is your up and down shift. Shifts up and down. K shifts up if it's positive, and negative or K shifts down if it's negative. So it shifts the way the sign, it matches the sign. Alright, so that's the equation in vertex form, and this is what we call the standard form. We're just translating this form into this form so we can get some information out of the equation. The information we can get the vertex out of this, but in this one we just see the two numbers that are the vertex. We don't need a formula. Alright, so we're going to look at transformations, transforming the equation to vertex form, and we're going to look at how that transformation changes from x squared. So here's my second example of a function in standard form that we're going to translate into vertex form. So in the first step here, we would factor out the negative 2 because we need to get that a value out of the front of this thing. We're still going to pull this 2 and bring it out here outside the parentheses. Leave myself a little bit more room. And then when we factor out the negative 2 out of these two values, we're going to get x squared minus 3x. Alright, now this one's a little messier than normal because when we did this formula before, we had to take this value and take half of it. So we're going to take negative 3 over 2 and we're going to square it, which is negative 3 times negative 3, we get 9 over 4. We're going to square the top number, square the bottom number. That's what we're going to add to this, 9 over 4, and we're going to subtract 9 over 4. So this one's a little messier because we're dealing with a fraction, but it's the same process no matter what values you have here. You're going to take half of this and square it, and that's what we're going to add. Now we're going to separate this out so it's a little clearer. We're going to take out the three things that we're going to factor. X squared minus 3x plus 9 over 4. We're going to insert, because the negative 2 is still multiplied by this other negative 9, or this negative 9 over 4, we have to include it inside a bracket. That negative 2 is multiplied by these three things and multiplied to this value. So we're including a bracket there to include this negative 9 over 4 in this negative 2 multiplication. So we're going to have to distribute that. So before we do that, we're going to distribute this negative 2. So we're going to have a negative 2 times x squared minus 3x plus 9 over 4. And we're going to have a negative 2 times negative 9/4, because this negative right here stays there. All right, so this is quite a bit of messy example here. We're going to get, now we can complete the square on this, and we're going to get negative 2 times something squared. Now remember, it was always half of this number, and since it's not a nice number, we could put 1.5 in there if you'd like. I'm just going to leave it in fraction form, negative 3 over 2. Now I'm going to compute this number now. So I've got positive 18 over 4, because remember, this is a whole number, so we would put it over 1 when we multiply. And then we have a positive 2 here. So this reduces to 9 over 2, which is 4.5. So we're going to get 4.5 and 2, so this is going to be 6.5 here, positive, and then we're going to have this negative 2 times x minus 3 over 2 squared. So this is my function after I've completed the square. Now it tells me some information. The vertex is the opposite of this number, which is positive 3 over 2, and the same number there is 6.5. So that means it transforms it, it moves it right 3 halves and up 6.5 from the original graph of x squared, from x squared. It also tells us this value right here tells us some other things. We're going to have a vertical stretch, we're going to have a reflection on x-axis, we're going to have a vertical stretch of a factor of 2 times. That means it's going to go up twice as fast, 2 times the function. So let's take a look at this on the graphing calculator and just see what it looks like. So I have my original function here, x squared, and then I'm going to type in my other function here. Let's just give it a minute to take effect here. Moving from one screen to another. So I have negative 2 parentheses x minus 3 over 2 squared plus 6.5. Now I'm not going to write, there's no way to write a mixed number on this one, so I'm just going to put 6.5 as a decimal there. Alright, now I'm going to zoom on 6 standard. There's our original graph, and here's the other graph. So as you can see, it's moved over 1.5 and up 6.5, and it's flipped over the x-axis, and it's a little narrower. It's twice as narrow. You can see that this is wider. This one's going up twice as fast, or going down actually twice as fast. If we were just looking at negative x squared, if we look at negative x squared, we can see that. Let's look at negative x squared as well. So I'm going to turn the graph off up here on positive x squared by just hitting enter on the equal sign. It's still graphing, but and I'm going to put in negative x squared here, so we're just going to look at that. Negative x squared. And we're going to take a look at that, and you can see how it's changed. So when it flips it over, there's my second graph, there's the original. So you can see that this one's wider, this one's narrower because of that factor of 2. It's stretching it by 2. And it's reflected from the original graph. If you look at the original graph again, here it is. We'll turn it on. And here is the original graph. So you can see that it's reflection, it moves to the right and up. Vertex was at 0, 0, and now it's at 3.5 or 1.5, 6.5. If you have any questions, give me an email, and I will attempt to do the best I can in an email. If not, call me during my office hour on Wednesday.